Hello everyone, welcome back to our channel. The next named reaction is Bamberger Rearrangement. Let's see the statement. The statement is acid catalyzed conversion of aryl hydroxyl amines to para-aminophenols. So this rearrangement is useful for the preparation of para-aminophenols. Substituted phenols can be prepared by using this particular rearrangement. If you see the general equation, we know that the general formula of hydroxyl amine is what? NH2OH. Our reactant is aryl substituted hydroxyl amine. So one of the proton is replaced with the phenyl group. You will get aryl substituted hydroxyl amine. Here we can have a substitution. It may be electron releasing group or it may be electron withdrawing group. Thereby you can also get different kinds of the products which are related to para-aminophenols. So the reactant is aryl hydroxyl amine. It is subjected to the acid catalyzed rearrangement. We will come up with what? Para-aminophenol. Let's see the mechanism. The starting material is aryl substituted hydroxyl amine. We know that this rearrangement is an example of what? Acid catalyzed rearrangement or not? Initially the acid is producing H plus ions. Here we are having lone pair of electrons. These lone pair of electrons donated to H plus. Thereby we will come up with NH single bond OH and another hydrogen. Oxygen loses its lone pair of electrons. That's why oxygen carries positive charge. If the oxygen is having the positive charge, means it is highly unstable. In order to attain the stability, what happens? The nitrogen oxygen single bond is subjected to heterolytic cleavage. Thereby we will remove H2O and NH. If you see the situation of nitrogen, the nitrogen is going to get what? NH plus. Okay. In this particular mechanism, what happens? If you see the product will be NH2OH. So we need to add OH group or not. For that purpose, we need not to take any kind of the nucleophile from the other side. In the solution only, we are having H2O molecules. These H2O molecules will be acted as the corresponding nucleophiles. So thereby what happens? For our convenience, I am writing the water molecule in this way. In our product, the position of OH group is what with respect to the amino group? This is the para position or not? That's why the water molecule is going to attack at the para position. It is an internal nucleophile. Thereby what happens? These pi bonding electrons can form a pi bonding like this, and these pi bonding electrons can form a pi bonding in this way. So that we will come up with this kind of moiety. Pi bond, double bond NH, single bond oxygen, hydrogen, and this will become positive charge. We know that again oxygen is having the positive charge. In order to attain its stability, what we need to do? We need to satisfy the valency. For that purpose, what we are doing? We are removing this hydrogen as H plus. Thereby what happens? We are going to have double bond, double bond, double bond NH, OH. So what is our final product? Single bond NH2 OH. If you see this moiety, here we have hydrogen, the hydrogen involving in the delocalization. In this particular situation, what happens? The hydrogen is removed in the form of H plus. Here the nitrogen is getting minus charge or not. So this H plus move towards what? This NH minus. Thereby we will have produce NH2 group. It's very simple mechanism or not? This is all about your Bamberger rearrangement. Here we do not have many number of applications. Simply we need to convert the aryl substituted hydroxyl amines to the corresponding phenols. Simply we need to have different substitutions at the phenyl group. You can all write the different kinds of the example.